In the realm of aviation, there exists a captivating enigma, the SR-72, renowned as the son of Blackbird. This cutting-edge project has allured aviation enthusiasts worldwide, beckoning us to explore its classified intricacies. So, with curiosity soaring high, let's embark on an exhilarating journey to unveil the secrets veiled beneath the surface of the SR-72. Before we dive into the SR-72, let's take a moment to appreciate its predecessor, the legendary Blackbird. The Blackbird, with its astonishing speed and stealth capabilities, pushed the boundaries of aviation during its time. It set numerous records and became a symbol of American aerospace prowess. Now its successor aims to take that legacy even further. The creation of the SR-72 aircraft is a work of engineering genius. Its fundamental design places an emphasis on the ability to withstand heat while maintaining its aerodynamic efficiency. When traveling at hypersonic speeds, an enormous amount of heat is generated, which must be dissipated by the aircraft's skin, which is made of cutting-edge materials. In 2018, the ambitious development of the SR-72 in demonstrator form got its start after the wheels were set in motion the previous year. This optional flight research vehicle will harness the astounding capability of not one but two full-scale engines, releasing their power to soar at an astonishing Mach 10 for brief periods of time. It will have a length that is roughly 60 feet long and is rather commanding. With its velocity increasing above Mach 5, hypersonic flight is about to take center stage, which presents aerospace engineers with a complicated riddle to solve. The process of developing the SR-72 was not a simple one. It included navigating a maze of complications, which demanded the collaboration and innovation of some of the most brilliant minds in the field of aerospace engineering. As Lockheed Martin began their voyage toward this momentous destination, they were met with a variety of obstacles, both technological and logistical in nature. The development of cutting-edge breakthroughs in propulsion, materials, and aerodynamics was required to create an aircraft that was capable of attaining hypersonic speeds greater than Mach 5. These challenges were warmly embraced by the engineers at Skunk Works, who are known for their legendary levels of skill. They relished the opportunity to redefine the limits of what was possible in the field of aviation. The Hypersonic Technology Vehicle 2, HTV-2 project, was one of the many possibilities that the Lockheed Martin Skunk Works investigated in their quest to achieve mastery of the hypersonic speed range. Initiated as part of the Falcon project run by the Defense Advanced Research Projects Agency, DARPA, this rocket-launched hypersonic aircraft had the objective of deciphering the mysteries surrounding the aerodynamics, aerothermal effects, guidance, navigation, and control of hypersonic flight. Every aspect of the SR-72's creation was a monument to human ingenuity and perseverance, from the design of cutting-edge propulsion systems that could survive severe heat and aerodynamic pressures to the development of new materials that could withstand the harsh environment of hypersonic flight. In April 2010, history witnessed the maiden flight of the HTV-2, a monumental occasion that captured the world's attention. Zooming through the skies at an astonishing Mach 20, 13,000 miles per hour, the HTV-2 pushed the boundaries of engineering, collecting invaluable data and insights into the challenges of hypersonic flight. The HTV-2's second flight, which took place in August 2011, made its place in history even stronger. The ideas for making the SR-72 came from what was learned on both trips, which changed the way it was made. The HTV-2 project was a step in the right direction. It was a key link between the SR-71's long history and the SR-72's lofty goals. The SR-72's astonishing capabilities are the result of a symphony of engineering wonders being orchestrated together. The aircraft will make a humming sound, similar to that of a turbine engine, when it begins the earliest stages of takeoff and enters subsonic flight. This will forcefully accelerate the aircraft forward. The performance of the SR-72, however, is taken over by an amazing dual-mode ramjet engine as soon as it crosses the threshold into the hypersonic speed range. This provides the SR-72 with the sheer power that is required to maintain flight in the treacherous region of hypersonic speeds. These kinds of smooth transitions between different propulsion systems shed light on the ambitious character of this project and bring to light the brilliance of the people who designed it. It is not just the cutting-edge propulsion systems that contribute to the SR-72's unparalleled speed and maneuverability. There are other contributing components as well. The application of cutting-edge aerodynamics is absolutely essential to the process of controlling the unpredictability of the forces that are encountered during hypersonic flight. The geometry of the SR-72 was fine-tuned by engineers using computational fluid dynamics, CFD models, and wind tunnel testing to ensure optimal performance and stability at mind-boggling speeds. The SR-72 can be used in many different situations, and it has the potential to greatly improve military capabilities. Intelligence, surveillance, and reconnaissance, ISR. The SR-72, which will be an unchallenged pioneer in the skies, will break down the barriers of traditional intelligence collection and surveillance operations. The aircraft will be capable of unfathomable speeds, which will allow it to race to important places in the blink of an eye, providing real-time data and considerably increasing military strategists' situational awareness. Precision strike operations. The hypersonic velocity of the SR-72 marks a quantum leap in terms of the capability of precision strike operations. The aircraft will demonstrate an unrivaled level of strategic agility by being armed with hypersonic missiles, such as the high-speed strike weapon developed by Lockheed Martin. These missiles will deliver devastating blows to targets that are both time-sensitive and heavily protected. Combat operations. The SR-72 is a potent force multiplier that may be optionally modified for combat missions. This configuration helps to bolster the long-term hypersonic roadmap for the United States Air Force. Because of its incredible speed and unrivaled maneuverability, it is a strong advantage even in the airspace that is the subject of the fiercest competition. Collaborative space exploration. Beyond its military applications, the SR-72 has piqued the interest of space organizations studying the possibility of using hypersonic aircraft for atmospheric research and launching payloads into space. This interest comes as a direct result of the SR-72's military usage. In the annals of aviation history, the SR-71 Blackbird has left an everlasting legacy thanks to its recognizably distinctive profile and its performance that broke numerous records. Since its historic retirement in 1998, Lockheed Martin has been tirelessly searching for a worthy replacement, which is what ultimately led to the development of the SR-72. This excursion, which was riddled with difficulties and required a great deal of effort, provided a front-row seat for multiple attempts to build high-speed aircraft, one of which was the Hypersonic Technology Vehicle 2, HTV-2. The incredible rocket-launched hypersonic aircraft known as the HTV-2 cemented its position in aviation annals with 2 successful flights in 2010 and 2011. It was able to reach speeds of up to Mach 20, which is equivalent to 13,000 miles per hour. The vast store of information and data that was gathered throughout the course of the HTV-2 project provided a vitally important basis for the creation of the SR-72. This persistent commitment to advancement and innovation remains the crux of Lockheed Martin's mission to perfect the SR-72, embellishing it with state-of-the-art hypersonic technology and unequaled capabilities. The SR-72's defining trait is its unwavering desire to outperform its famous predecessor, the SR-71, in every way possible. Because of how carefully it was designed and how well it was built, the SR-72 is supposed to change the way that strategic reconnaissance is done. Its greater speed, range, and operational adaptability mean that military planners and decision-makers will continue to use it as an important tool. The SR-72, which is fitted with hypersonic missiles and has the ability to travel across continents in a matter of hours, exemplifies the very definition of capabilities for both fast response and deterrence. The SR-72 can easily penetrate even the most heavily protected airspace, thanks to its exceptional speed and cutting-edge technologies. This provides the United States with a significant advantage in the ever-changing face of global security. The creation of the SR-72 is not without obstacles, as is the case with any very bold endeavor. Engineers at Lockheed Martin's Skunk Works are dedicated to finding solutions to the challenges of hypersonic flight, such as reducing the impact of severe aerothermal effects and maintaining the aircraft's structural integrity. Another impediment is the high price tag attached to discovering, creating, and deploying such groundbreaking technology. To tackle these challenges head-on, Lockheed Martin has formed partnerships with leading research institutions, universities, and industry experts. The collaborative approach allows for the pooling of knowledge, resources, and expertise, accelerating the development process and facilitating breakthroughs in hypersonic technology. However, Lockheed Martin remains unflinching in its determination to prevail over these challenges, which is supported by the unflinching backing of the United States Air Force and the company's unyielding commitment to a long-term hypersonic plan. The long-awaited maiden voyage of the SR-72 demonstration, which is scheduled to take place in 2023, will mark the beginning of a critical stage in the process of maximizing the potential of this game-changing aircraft. Although the full-scale SR-72 is expected to enter service by the year 2030, its mysterious features and capabilities are still shrouded in mystery. They are waiting for the day when they will be revealed to the rest of the world. The SR-72 is a striking symbol of the unwavering commitment of the United States to preserving both national security and global stability. This dedication is symbolized by the aircraft's name. The SR-72 confirms the nation's will to maintain its strategic edge in the face of competitors who are investigating new paths for developing powerful armaments and defensive systems. The capacity of the SR-72 to travel across continents in a matter of hours, in conjunction with its stealthy design, means that prompt responses may be provided to newly developing threats. Because it is armed with hypersonic missiles, it poses a severe threat to potential rivals. This demonstrates how essential it is to preserve peace through superior military might. Furthermore, the SR-72 project strengthens the industrial and technological capabilities of the United States, which in turn stimulates economic growth and drives innovation in industries that are related to it. It acts as a driving force behind the development of hypersonic technology, which has a wide range of possible civilian applications, from high-speed commercial transport to the study of the atmosphere. Excitement and anticipation are resonating throughout the aerospace community and beyond, as the SR-72 project races toward the year 2023 when its first flight is expected to take place. This groundbreaking airplane serves not only as a demonstration of human creativity and the superiority of engineering, but also as a symbol of hope and aspiration for the generations to come. The pursuit of hypersonic flight exemplifies the unquenchable yearning of the human spirit to break through barriers, triumph over trials, and discover the mysteries of the heavens. The SR-72's impact extends far beyond its military applications and serves as a source of motivation for all those who have the courage to dream big and go after the extraordinary. The SR-72 will be a cherished part of the rich tapestry of aircraft history. It will always remind us of the dizzying heights that human ambition and creativity can reach. While the rest of the world waits for the SR-72 to make its grand debut, the journey goes on, driven by an unquenchable thirst for information and a never-ending desire to find out more. Every time the SR-72 makes a loud boom, it pushes humanity forward. It lights the way for future generations to take advantage of all the possibilities that the sky and beyond have to offer. As Lockheed Martin continues to push the boundaries of aerospace innovation, intriguing clues and whispers about additional top-secret projects have surfaced from behind the veil of secrecy that has been erected around them. One such project is around the possibility of the existence of even another high-speed jet, potentially one that is even faster than the SR-72. This project is frequently veiled in rumors and mystery. Aerospace aficionados and analysts have spent the better part of the past few years poring over a variety of sources, such as government pronouncements, patent filings, and expert analysis, in an effort to piece together the fundamentals of this enigmatic high-speed aircraft. Despite the fact that Lockheed Martin has chosen to remain silent regarding the issue, certain hints have surfaced, which have stoked the interest and curiosity of aviation enthusiasts. The potential creation of a high-speed strike weapon, HSSW, is an exciting prospect that could arise in the future. It is currently unknown what exactly the HSSW is, although it is thought to be a hypersonic weapon system that extends the capabilities of the SR-72. This is despite the fact that particular information remains elusive. The ability of the United States to project power and react fast to new dangers would be considerably improved by the development of such a weapon, which would be capable of traveling at speeds that defy human comprehension. In addition, there has been some talk about the possibility of Lockheed Martin working with other defense contractors and space agencies to develop a hypersonic spaceplane. This would be a vehicle that could travel through the Earth's atmosphere and enter the vicinity of space. This ambitious idea is in line with existing attempts to investigate the synergies that exist between hypersonic aircraft and space research. As a result, it has the potential to usher in a brand new era of aeronautical operations. A parallel race for global dominance is currently taking place, one that not only involves technological breakthroughs, but also the strategic consequences of those gains. This race is reaching new heights as the quest for hypersonic flight reaches new heights. An arms race has been triggered among the main world powers as a result of the development of hypersonic capabilities. Each of these powers is seeking an advantage in the cutting-edge field of hypersonic military aviation. The United States of America, China, Russia, and a number of other countries are making significant investments in the research and development of hypersonic technologies as a result of the potential advantages that these technologies could provide. The capabilities of hypersonic weapons, which include improved intelligence gathering and reconnaissance, as well as speedy and precise strike capabilities, have the potential to completely transform modern combat. China, in particular, has made significant strides in hypersonic technology development. The country has successfully tested a range of hypersonic vehicles, including glide vehicles and scramjets. These advancements have raised concerns among defense analysts, prompting other nations to redouble their efforts to maintain their competitive edge. Russia, too, has demonstrated its commitment to hypersonic flight. The country unveiled the Kinzhal air-launched hypersonic missile, capable of reaching Mach 10 speeds, providing it with a potent weapon for challenging adversaries. Kinzhal's successful deployment has added an extra layer of complexity to the global security landscape. In response to these developments, the United States Air Force and other branches of the U.S. military have intensified their hypersonic air-breathing weapon concept, HAWS, program. HAWS aims to accelerate the development of air-breathing hypersonic cruise missiles, a crucial element of the U.S.'s hypersonic arsenal. Additionally, the Defense Advanced Research Projects Agency, DARPA, is leading the effort to develop a new class of hypersonic weapons to maintain the nation's technological superiority. The increasing availability of hypersonic capabilities has a variety of difficult ramifications for strategy. Hypersonic weapons are able to maneuver in unpredictable ways, in contrast to conventional ballistic missiles, which go along predetermined paths. As a result, it is significantly more difficult to intercept and defend against hypersonic weapons. This flexibility results in an increase in their effectiveness, but also raises concerns that the existing deterrence balance may become more unstable. As more nations obtain the ability to travel at hypersonic speeds, worries over escalation and arms control emerge. The lightning-fast speed and incredibly short reaction times of hypersonic weapons could potentially increase the risk of erroneous calculations or the unintended escalation of a conflict. It is essential to keep communication lines open and transparent, and to put in place measures that generate confidence in order to reduce the likelihood of misunderstandings and unexpected effects. The development of hypersonic weapons has also reignited debates about arms control. Since hypersonic missiles are not officially covered by the likes of the new START Pact, some have questioned whether or not we need new, comprehensive agreements to deal with this growing problem. In the age of hypersonic flight, the future of weapons control depends on striking a compromise between national security objectives and international stability. The significance of hypersonic flight extends beyond the realm of military applications. The aerospace industry, always at the forefront of innovation, is witnessing a surge in research and investment focused on commercial hypersonic travel. Companies like SpaceX and Blue Origin are looking into the possibility of reusable space planes that could take people to the edge of space or speed them around the world at speeds that are hard to imagine. The technology for civilian hypersonic travel is still in its early stages, but the rapid improvements in military hypersonic flying are paving the way for future commercial uses. Exploring how to move faster than the speed of sound has implications for space travel as well. Hypersonic vehicles could be a bridge between air travel and space travel, making it easier to get to low Earth orbit and places beyond. The idea that hypersonic spaceplanes could be used as space shuttles for both goods and people is an exciting idea for the future of space travel. The SR-72 is the torchbearer of progress, a symbol of humanity's unrelenting pursuit of greatness and the unexplored horizons that lie ahead in the sky and beyond, much as the SR-71 Blackbird's legacy has inspired generations of aerospace pioneers. By taking on the risks and rewards of hypersonic travel, we enter a new era of aviation that has the potential to radically alter our world. Here, the previously unthinkable becomes a reality as the future takes to the skies. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.